Hello guys, welcome back to the channel. Today we're going to be doing another surveying problem. In this case, we're going to be performing some leveling calculations. So we were given a set of data for a differential leveling survey and some measurements. And we need to find the height of the instrument at the benchmark and the elevation at the turning point. So the information we were given is an elevation reading at the benchmark and a back sight at the benchmark, and then we were giving a foresight and a back sight measurement each for the turning point. So I'm going to show you how to do those calculations. So if you remember from surveying class, usually when you're doing these, you draw a little table to kind of help you out. So I remember when I was taking surveying class, sometimes I would forget how to set up the table and I'd get confused. But when I was studying for my FE, I was able to find a way to remember the table consistently. So I'll show you how. So instead of drawing the table just like in order, I kind of go from the outside to the inside. I'll show you what I mean. So what helps me remember it is this. So it's station, and then over here it's elevation. So station, elevation, and then back sight, foresight, and then in the middle it's height of the instrument. So that's just what helps me remember it. Station rhymes with elevation, and then back sight corresponds to foresight, and then the height of the instrument is right in the middle. So now we'll move on to filling in our table. So we have the benchmark and we have the turning point. So the first thing that we'll do is we'll fill in our benchmark data. So we have a elevation reading at the benchmark, which is 101.5. And then we have a back sight reading here, which is 7.25. And then for the turning point, we have a foresight and a back sight measurement. So for the foresight, we have 1.85. And then for the back sight, we have 3.10. So there's our table filled out. And then what we need to find is the height of the instrument at the benchmark. So we need to find this right here. And then we need to find the elevation at the turning point, which is this right here. So one thing that you need to know about the surveying problems for the FE exam is that you're not given the formulas for height of the instrument, foresight, back sight, elevation, all that stuff. You're not given any of that in the FE reference manual. So you want to try and remember these. So we'll start off with the height of the instrument. The height of the instrument is the following formula. So height of instrument is equal to the elevation plus the back sight. So in this case, it's going to be 101.5 plus our back sight, which is 7.25. So the result for this one is going to be 108.75. So that's our answer for the first part of the problem. So now we need to know the elevation at the turning point. So the way that we find that is the following formula. Elevation is equal to height of the instrument minus foresight. So in this case, it's going to be the height of the instrument that we just found. So here I'll go ahead and just fill that in for us. So we know this height of the instrument now. It's 108.75. And the elevation here at the turning point is going to be the height of the instrument here that we just found minus this foresight over here. So it's kind of like, going in an arrow, kind of like in this direction. So let's go ahead and just do that calculation. 108.75 minus 1.85. That is going to equal 106.9. And we'll go ahead and finish our table. 106.9. And that's going to be our answer for the second part of the problem. So as you can see, these surveying problems have a lot of moving parts. You have to remember how to set up the table, and then you have to remember these formulas. So I hope that our videos really help with that. Make sure to subscribe if you want to see more content covering videos about all the FE topics. And also make sure to leave a like and leave a comment with any feedback or what you would like to see us cover next. And we will see you in the next video. Thank you.